Hey guys, welcome back to Learning Kotlin Live. This is the episode 54, and today we're going to learn more about coroutines. And let's see. Exactly, I am going to learn more about coroutines, and you're gonna see what obstacles I have run into, and trying to um, get over them, I would say. So we were at coroutine contacts and dispatchers, I guess. Nope, we were at composing suspending function, and we're supposed to be at coroutine contacts and dispatchers today. So I think after learning this, things are going to be a lot clearer because that's just my guess, because I've heard that this is one essential part of coroutine. So coroutine contacts and dispatchers. Coroutines always execute in some context, which is represented by the value coroutine context type defined in a Kotlin standard library. Let's take a look at this coroutine context, and there's a Okay, so there is only a key and an element. Hmm. Don't quite get it yet. So the coroutine context is a set of various elements. The main elements are the job of the coroutine, which we've seen before. Wait, what is it extending from? Is it inheritors? Nope. I don't get it. What do you mean by there's a job attached to it? Get fold minus key plus. I don't see any job from here. Yeah, I don't get it. The coroutine context is a set of various elements. The main elements are the job of the coroutine, which we've seen before, and its dispatcher. So the main elements are job and dispatcher. And we're going to talk about, we have already covered job, so we're going to cover dispatcher today. So dispatchers and threads. Coroutine context includes coroutine dispatcher, see coroutine dispatcher, that determines what thread or threads. Oh, so it could be plural. What thread or threads the corresponding coroutine uses for its execution. Coroutine dispatchers can confine coroutine execution to a specific thread, dispatch it to a thread pool, or let it run unconfined. What does run unconfined mean? Let's see. Confined, restricted to oh, so that means there are no rules, I guess. Oh, coroutine builders like launch and async. Async itself is a coroutine builder. Can't quite remember. Let's review it for a while. So async. Is there anyone doing? Nope. Async. So coroutine using async sample and blah blah blah. Async is a coroutine builder, is defined as extension on coroutine scope. Wait. This is okay. Yep, this is what I'm looking for. Async. Where's that async? I don't see any async here. Where's that async? Oh, here it is. It's a coroutine builder, and do something useful. One is a coroutine. Oh, I remember now. So async means don't run it until maybe actually no. Wait. If there is no um oh, lazily started. Oh, if yeah, it's default to be not lazily started, but anyway. So yeah, async is a builder, and it builds another it builds a subcoroutine, I would say, because everything is concurrent natively. If here it is, sequential by default. Even if we run some suspend function, they are sequential by default. But with that async, we can build a coroutine which is non sequential. So let's get back to it. Coroutine builders like launch. Launch is, I think launch does nothing particularly right. It's more like, can't remember, but anyway. Accept an optional coroutine context parameter that can be used to explicitly specify the dispatcher for new coroutine and other context elements. So we can launch. Let's take a look at the result first. So we launch a coroutine. And it's in a run blocking block, so so this launch is related to the run blocking, but this launch is related to the main thread, and this is just related to the default, which is actually it's dispatched to a default dispatcher, and this one it is related to a new single thread. So probably because this one is everything is in run blocking. So wait. So this is dispatched to the run blocking coroutine, and there's a thread.current. This makes things a lot clearer to me, at least. So aha. So this add coroutine number 3 actually is it's like a lambda or function pointer. I don't know exactly what this means, but it means the coroutine number 3 on main, and this is the coroutine number 2 on main thread. So similarly, I'm working in thread, current thread.name. So this is actually a thread name. So this is not the main thread itself. It's a thread which has the name main thread in it. I would say that's what I believe. But hey, why is there these items as well? So it actually is main thread, but just that main thread is adding some um, modifier or just some metadata to it. So anyway, yes, this is on the main thread and main thread. So we have dispatched it. So everything is run sequentially because it's in a run blocking coroutine. And everything is dispatched. So like this is dispatched to a main thread, and main thread is currently blocked by the run blocking. So these two won't be launched before. Oh, not everything, not these two. It's this one and this one. They won't be run before everything is launched, but hey, there's an exception here, and I sincerely don't know how I should look at this. Let's move forward and see if it's explained. But initially I was expecting these two to be executed last, and these two would happen somewhere in between. So while launch is used without parameters, it inherits the context and thus the dispatcher from the coroutine scope that it is being launched from. So that means the run blocking coroutine which runs in the main thread. So these two, there is a unconfined, but it is not blocking. It is on a main thread, but it is not blocking. That's probably how it is to be explained. When launch is used without parameter, this is something we just read. Dispatchers.unconfined is a special dispatcher that also appears to run in the main thread, but it is in fact a different mechanism that is explained later, so that's why. And the default dispatcher that is used when coroutines are launched in global scope is represented by dispatchers.default and use shared background pool of threads. So launch dispatchers default blah 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 uses the same name as global scope.launch. Wait, what? Oh, so that's the global scope. The default one is a global scope one. Okay. And the default dispatcher. So global scope. So yeah, global scope, they are all global scope coroutines are run on the default dispatcher. This is something that is I hope I have learned earlier. So I would actually recommend reading this document first if you are new to coroutine. It makes a lot of things clearer if you are familiar with the thread, how thread works in Java. So the last one, new single thread context. Create a new thread for the coroutine to run. A dedicated thread is a very expensive resource in a real application. It must be either released when no longer needed using close function, okay, or stored in a top level variable and reused throughout the application. Makes sense. So here's the confined and versus confined dispatcher. The dispatchers.unconfined coroutine dispatcher starts coroutine in a caller thread. but only until the first suspension point. Ha! So here's the concept of suspension point. That's something I already know, but I never learned in this document till now. After suspension, it resumes in the thread that is fully determined by the suspending function that was invoked. Unconfined dispatcher is appropriate when coroutine does not consume CPU time nor updates any shared data that is confined to a specific thread. Okay. So it starts in a caller thread. So because main coroutine was on main thread, I mean the run blocking coroutine is on main thread. So this dispatcher's dot unconfined is on the main thread as well, and that means after suspension, it resumes in a thread that is fully determined by the suspending function that was invoked. So if there are multiple suspensions, so because print alone itself probably has no suspension O, or we can say the suspension point is at the very end of it. So this print loan is fired directly on the main thread. So that's why we're seeing this. And after this, the main thread is, well, this is first dispatched. And this is dispatched as well, but it also, in the meanwhile, also on main thread, the priority of these dispatchers dot unconfined coroutine would be set to the topmost for once, and the only until the first suspend point is reached. So the suspend point is actually the return of the end of this coroutine. So yeah, this is executed. Then dispatchers.default and new single thread contents, these are both scheduled, and not until the latest suspension point of this whole main run blocking coroutine, this is unblocked and this can be executed. So that's why this is executed last. On the other side, by default, the dispatcher for the outer coroutine is inherited. The default dispatcher for run blocking coroutine in particular is confined to the invoker thread, so inheriting it has the effect of confining execution to this thread with a predictable first in first out thread scheduling. So yeah, that's why, because the whole main blocking is first scheduled, then the this launch. So probably we'll see this first. I'm working in thread main at the coroutine number 3 and delay, and because this is the first suspend point, so these two will later be scheduled, I would say. But I don't know when this will come in. So I'm expecting, I'm working in thread main, then I'm working in thread main again. Oh. Actually, I would expect I'm working in main thread. I'm after delayed in thread main, and this and this. That's what I'm expecting. And nope, I'm wrong, totally wrong. So this is executed first. This is yes, this is indeed true. But later this is blocked, and so these continues, and this is run. Yeah, and actually I would say these two are dispatched, and this is later run, and then probably this one and this one. So the coroutine that had inherited context of run blocking continues to execute in the main thread, while the unconfined one had resumed in a default executor thread that, oh yeah, it is later resumed in default executor instead. And it's in default executor, and this is not default dispatcher. Interesting. But anyway, we know that now we are certain that yes, before the first suspension point, well, these unconfined be executed. So here it said, wait. So the coroutine, blah 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 blah. What? Where? So the coroutine that had inherited context of run blocking coroutine to execute in the main thread, while the unconfined one had resumed in a default executor. Yeah, this is something we already covered. Unconfined dispatcher is an advanced mechanism that can be helpful in certain corner cases where I think this means that we don't usually use it, where dispatching of coroutine for its execution later is not needed or produces undesirable side effects. We don't want it to be dispatched later, because some operation in the coroutine must be performed right away, but it only performed right away until the first suspension. That's weird. Unconfined dispatchers should not be used in general code. Here it is. Let's see. That's the rule. That's the sum of rule. Okay, I think debugging would be the last topic we can cover today. Debugging coroutines and threads. Coroutines can suspend on one thread and resume on another thread. Even with a single threaded dispatcher, it might be hard to figure out what coroutine was doing. Yes, exactly. I totally have no idea how coroutine is running until today. I was doing where and when. The common approach to debugging applications with thread is to print the thread name in the log file on each log statement. What is the 6 for? This feature is universally returned 6, I guess. Yeah, 6 and 7 would be returned. This feature is universally supported by logging frameworks where when using coroutines, the thread name alone does not give much of a context. So Kotlin coroutines include debugging facilities to make it easier. Well, that's really handy. So I guess the aforementioned has Kotlin X coroutine debug open. So, oh, actually no, this is something that's different than what I expected. Anyway, main coroutine number 2. So we get a sync and an async. So these two are both scheduled, and they are not lazy, so they are directly running. So I'm computing a piece of the answer, I'm computing another piece of the answer, and so yeah, coroutine 1, this is the run blocking one. Let's see the full code to make sure. Yes, it's in the run blocking. So this is the coroutine 1. And this is a coroutine 2 and coroutine 3. So yeah, exactly. The answer is 42 is on 1 and everything is on main. That's probably the attribute of that async builder. There are 3 coroutines, a main coroutine run blocking 1 and 2 coroutines computing deferred values number 2 and 3. They are all executing in the context of run blocking and are confined to the main thread. The output of the code is blah blah. The log function points the name of the thread in square brackets. And you can see that it is the main thread, but the identifier of the currently executing coroutine is appended to it. This identifier is consecutively assigned to all created coroutines when debugging mode is turned on. Yes, that is handy. You can read more about debugging facilities in the documentation of new coroutine context function. Okay, I think that's all for today. And I feel like this is a really informative lesson of coroutine. So I finally start to understand what coroutine is for. Actually, I know what it is for, but I don't know how it is designed and linked to the Java world. And now I finally have some hint. So that would be all for today. See you guys next time in Learning Kotlin Live episode 55. And because this Saturday or Sunday, let's take a look at it. Code Jam. I think it's Sunday. It's 1 to 3:30 and in UTC, and it would be 9 to 11:30 in of April 13, which is the day after tomorrow, and that's Saturday, is it? Yeah, it's on Saturday. So yeah, wait. So yeah, it's Saturday. So I will be writing. I think if time permits, I will be joining this round as well. While I don't believe I can pass it because I only feel like I will be. I feel like round 1C would be my best shot, but anyway, I think I'm going to record my me joining this, but because collaboration is strictly prohibited in any round after round qualification, so I won't be streaming it live, but I will probably record it and later upload it, and you can just laugh at me later if you want to. So yeah, that's just a brief about how I'm going to join my next my casting tomorrow, and maybe my casting the day after tomorrow. And I'm also thinking of skipping an episode tomorrow because I don't know, just for preparation. I don't think I would really prepare for it, but I'm just tired of casting 6 days in a week. Yeah, so that's everything that I want to talk about today. So yeah, we will resume this dispatchers talk in the next reading Kotlin manual episode. That's all for today. Bye bye.